what we're going to get. Well,
Planetary geologist Eugene Shoemaker and his wife Carolyn specialize in asteroids and comets. They know that collisions play a key role in shaping the solar system. Tonight, they're at Mount Palomar in Southern California. Here, with an 18-inch telescope, they will search for objects that one day might cross the Earth's orbit.
Okay, well, let's hope that tonight's the night for a new comet, Shoemaker. It's about time.
39 degrees, 35 minutes.
Okay.
By carefully aligning the telescope, a series of photographs is taken of the same area over a period of time. When the photographs are compared, they can see if an object has moved. If so, it might be a comet. This work has led Gene Shoemaker to a theory about the Uranus moon Miranda.
Here's an icy satellite with peculiar blocks of terrain on its surface, patches that are just distinct, that are young features geologically, some roundish in outline, some rectangular in outline, that represent a localized spot of geological activity. And the question is, how would this come about? How would it happen that you have these funny blocks of terrain and not reprocess the whole surface of the satellite? Now imagine that Miranda, when it was first formed, was warm, and the rocky constituents settled to the core, and the ices settled to the outside. So you had an icy mantle and a rocky core. Now you smash the satellite up into pieces that are scattered just randomly in the orbit, and then they're reassembled without regard to whether they were once in the core or once in the icy mantle. So you'll have big chunks of rocky material, big chunks of ice. As the satellite warms up again, those chunks want to find their proper home. The rocky part, which is denser, wants to go to the center, the icy parts to the outside. You could get melting, you could have eruptions at the surface, and you could form a local feature, such as these very strange patches that we see on the surface. So I think we're seeing the evidence on the surface of the inside of the satellite trying to get back to its proper and original configuration after its last catastrophe.
Following the collision, Miranda's fragments stay in orbit around Uranus. Over time, the debris is pulled together by gravity and begins to reassemble into a moon. A patchwork of ice and rock, its interior begins to warm. Melting ice flows onto the surface to form a new landscape. Miranda has been the highlight of the Uranus encounter. As information continues to stream in, the spacecraft is bound for its next rendezvous, 3.5 years away. Neptune, the final and outermost planet on the Grand Tour. Its most prominent feature is a giant spot. Seen for the first time by Voyager, it's similar to the one on Jupiter. The presence of a storm surprised Andrew Ingersoll, an atmospheric scientist at Caltech. The amount of sunlight that reaches Neptune is equivalent to twilight on Earth. Because energy from the sun drives weather, this dynamic atmosphere was totally unexpected.
The big surprise for me was that here you have this planet Neptune, way out in the solar system. It receives a few tenths of a percent the amount of energy that the Earth does. And so you'd expect the weather to be dull. And what do we find? It's the windiest planet in the solar system. Storms are moving around at speeds of 1,400 miles per hour. It's If Columbus had had winds like that, he would have crossed the Atlantic in a few hours. It was amazing, simply amazing.
To study the weather on Neptune, Ingersoll and his colleagues developed a computer model of its atmosphere.
The computer models that reproduce the complicated behavior that we see have a couple of common elements. Obviously, they don't have continents and oceans, so there's nothing for the storms or the winds to rub against. But in addition, they have very little friction. These are atmospheres without turbulence. If you start something in motion, it just goes on forever. If you start winds in motion, they go on forever. It does all the things that the real thing does. Look at it.
You know, that's great.
This is hydrodynamics here. The only thing I'm still worried about is this great dark spot actually rolling, or is it just kind of rocking back and forth now?
Just oscillating.
Yeah, I mean, is it rocking or rocking or rolling? That's the question. All right.
Without friction, there is no turbulence. So, Neptune's dark spot rocks continually back and forth like a pendulum. But what could cause the high winds?
I think I understand that now. As you turn down the energy supply, you reduce the friction, and that allows the winds to build up. You reduce the turbulence. It sounds simple now, but it sure was a surprise when we first saw those winds.
A violent storm on a cold and sunless world. Howling winds that defy logic and humble the intellect. And there were more surprises still in store. In Flagstaff, Arizona, a branch of the U.S. Geological Survey is solely devoted to the growing field of space geology. Here, nearly 100,000 images from Voyager are stored on computer tape for easy access on video display terminals. Already there is enough data from the encounters to keep scientists busy well into the next century. Geophysicist Larry Soderblom is interested in Neptune's largest moon.
I need some Triton data up. It's a PA tape. I need 494 mounted on iFlight 2. Sure. Okay, thanks.
Triton is one of only 3 moons in the solar system with a permanent atmosphere. Voyager sent back 2 sets of images to create a mosaic of Triton. Where they overlap, the features appear in 3 dimensions.
The spacecraft was flying past Triton, so one set of images would be acquired from one angle and another set from another angle. If we could look at those in stereo, it was possible to see what was on the ground and what was above the ground. The 2 images were projected onto a sphere. And they're shown in this view. One of them is in red, one of them is in green. And so features that line up are shades of yellow. And you can see up in this region, all the features seem to line up pretty well, with the exception of 4 major features here. And in fact, this is where we first noticed the active geysers. If we blink the 2 images, you'll see these dark markings dance across the surface, whereas the others are locked onto the surface and perfectly registered.
What Soderblom discovered are giant plumes of gas rising from a field of nitrogen ice on Triton's surface. Plumes of gas erupting from geysers on a frozen moon at the very edge of the solar system. Triton would be a fitting climax to the grand tour. At 5:14 on the morning of August the 25th, 1989, Voyager 2 bids farewell to Neptune and heads into deep space. A 12-year, 4 billion-mile odyssey finally comes to an end. 6 months later, on Valentine's Day, Voyager 1 turns its cameras on for a last look at our distant family of planets. Earth appears but a tiny pinpoint of light.
There's no real science in such an observation, but to look back and see our tiny, and I tell you, truly insignificant Earth sitting there in the blackness of space, and to take an image of it from out near the edge of the solar system, it's emotional.
It has been said they dared to go where only we could dream. Today, the men and women of Voyager celebrate this splendid achievement.
Voyager was the little spacecraft that could. It wasn't designed to last beyond Saturn. It almost didn't. It developed many problems, and I think the greatest achievement was the way the engineers fixed it en route with nothing but radio waves to communicate with. They reprogrammed the computer. They redesigned the system that keeps it aligned properly. The way they could fix it over 1 billion miles was truly remarkable.
Voyager 2 is headed sort of towards Sirius. Well, now Sirius is the brightest star in the heavens. So if you're camping in the Sierra some night and you look up and you find Sirius, you might say to yourself, you know, there's a little craft that's headed that way. It won't be close to Sirius for nearly 300,000 years, but that's the way it's going.
The human species is going to be out there in the outer solar system. I can't tell you how long it will take. It'll probably be a few centuries. From that perspective, Voyager is the ultimate pathfinder. It's the one who showed the way.
Voyager is destined to wander among the stars. Bolted to its side is a gold-plated record. On it is a message from mankind to any alien intelligence. It says, "This is a present from a small and distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so that we may live into yours. We hope someday, having solved the problems we face, to join a community of galactic civilizations." This record represents our hope and our determination and our goodwill in a vast and awesome universe.
Здравствуйте, приветствую вас.
धरती के वासियों की ओर से नमस्कार.
Sia nibingalela makawe, snipisela inkonzo ende. Ria dumelisa marena.
Hello from the children of planet Earth.